Hello everyone, I am Rupok and this is my final report for my GSO project PyGoat. The purpose is to give developers and testers a platform for learning how to test application and code security. PyGoat is written in Python and uses Django web framework as a platform. It has previously PyGoat was in blue theme. I have added dark theme. This UI is pretty much improved and it is relatively modern look. Also, I have created a new logo for PyGoat also. So as you can see, the older version of PyGoat looks like this, and the newer version have separate section for also top 10 2021 version, Sans 25, and also top 10 2017 version, and all the labs are inside those sections. Let's get started with the labs. So first we have broken access control. Access control, sometimes called as authorization, is how a modern web application grants access to its content. And the newest addition of this section is lab 3. So some user credential is provided, admin and admin password, and a normal user credential. Let's log in with the admin credential first. So as you can see, there is some option for secret. So this is a page for secret, and this option is given for admin only. If we log in with the normal user, I can't see the option. So they suggest that that page was made for admin only, but authorization was not applied on that page. So a user can still access that page because that page was public. So just hacker need to do is like guess the URL. There are some automated tools to do this thing, and hacker can get all the open URLs which are available and try one by one. In the next section, we have cryptographic value. For the lab 1, some credentials are given, username and password hashes. So let's detect what type of hash is this. So the hash is an MD5 hash, and MD5 hash is really deprecated nowadays because we have hash clashes, and there are some online databases where you can search the hash and get the password for normal passwords. for lab tools, again some user ID and password hash are given. Like this time they use some strong hashing algorithm like SHA-256. But again, if the password is weak itself, we can find the hash in those online databases. So first thing, we should not use weak passwords, and along with strong hashing algorithm, we should use sorting web concepts also. For the lab 3, again, we have given some user credential, and this time the authentication system is secure. But alongside the password encryption, there are some other parameters which needs cryptographic protection, like cookies and tokens, etc. Like in this case, if you look into the cookie is unencrypted, and you can see the user timestamp in it. So we can simply verify the cookie and get the admin access. That's why must use encryption in cookies also. We have injection, so this is one of the broad category, and SQL injection, command injection, OS command injection, template injection are the examples, and newest edition of Flavis is template injection. So most of the modern websites uses templates, like Django uses Django Ginger template, and there are some other template engines. So in this lab, I have used Django's default template engine, and this is a blogging website where I can add a blog, and it accepts HTML parameters also, so it renders the HTML, so like this. And but I can give some template specific parameters also, and it will be rendered. Like in this case, I can add some script in the HTML, and it would reflect as an access attack. Or I can import the admin panel also in the log itself. Also, there are some debug parameters in Django's template, so I can use that also. So next we have insecure design. Insecure design is a broad category where the coding fault is not the problem, but the problem arises when it priors to the program. Lack of planning can cause this type of problem. This problem demonstrates the movie ticket selling service, where they are giving 5 free tickets to everyone, and they will start streaming the movie once all the movies are distributed. So in this case, a user have to wait until all the tickets have to sold. But there are some easy tricks to bypass the system, because the system is not authenticated correctly. So as you can see, I have already claimed my 5 free tickets, but I can't see the movie because there are 55 tickets left. Next, there is security misconfiguration. So this lab 2, and in lab 2 there are some Django have some debug route where all the debug information are leaking. So we have to start the server up with debuggable roles. In lab 2 we have seen that the debugging information can leak important stuff and configuration, but it can also leak some secret if there is internal encryption of cookies and tokens. This lab is about exploiting them and avoiding those kind of mistakes. Next, we have using components with known vulnerabilities. So every day new vulnerabilities are detected in modules and dependencies, and this lab is about such kind of vulnerabilities found in below module version 8.0.0. And this vulnerability has such potential that it can terminate the server or give access to more such extent. You can use depend bot-like tools to get updated about the known vulnerabilities and should update our dependency also. So this utility have an image of system where we can apply some mathematical equation on that image. So, but if we terminate with some special code like exit, so we have the potential to terminate the server. As you can see, this is not the standard error message of Django. If we say the console, there is some system exit. So Django is secure itself, so it can recover. But if it was like simple Python HTTP server, it would be dead by now. And this is the code for the lab. Next, we have identification and authentication failure. So previously known as broken authentication. So the newest edition lab 2. This lab is an admin of the login page, and it has such a security measure that it blocks user for 5 successive wrong password entries. So this feature seems to be a good security measure, but somebody can take advantage of this feature, and the actual admin will be in a problem. This is an example of insecure design also. There is similar mechanism in many systems. So as you can see, if the failure attempt equal to 5, then the admin account is locked. So what I can do is just do 5 incorrect password entry, and admin won't be able to access the admin for at least 1 day. And for lab 3, we have 3 user credential. So user 1 #1, user 2 #2. So So I have successfully logged in as a user 1, and I can see that the cookie is also pretty much secure. Encryption is used, so there's all things seems to be fine. But if we see the code, they are storing the session token. Let me see the code. So the code, they are storing the cookie in the database, but while log outing, they are setting the cookie null to the client side, but they are not deleting the session token from the database. So what one can do is use the previous token and logged in. You can use that token for login purpose. So in such cases, cookie stealing may happen. Next, you have software and data integrity failures. So one thing, we should cross-check the SHA-1 fingerprint and MD5K to cross-check any downloaded file. This lab have a vulnerability like this lab have some static file download, but it asks for a name. So this is the actual method downloading the file, and the previous link was given by a hacker. So as you can see, the page is same, but the file is different. So access setting has been used to modify the request. So it won't happen if the file integrity is checked. Next, you have insufficient logging and monitoring. Logging as exploitation interface. When unsanitized user input is passed through a database or HTML, there is a chance of injection. The same goes for logging also, and this level is about that. This is a login page that has active monitoring, but some raw data is passed in the log file, giving access to inject fake logs. So if a user is so a hacker can do is like spam the log file and add some fake log also using the vulnerabilities. So it has some coding background also, where we can play with the code itself and improve the code bypass the vulnerabilities. Next, we have server-side request forgery. Server-side request forgery flaws occurs whenever a web application is fetching a remote resource without reading the user's URL. This is extremely dangerous, and a hacker can get access to internal files using path transversal or remote access. This lab has some mechanism like that. This is blogging website where user can see some blogs, and this is a discussion portal where a user can find errors in the code and modify the code, improve the code quality. So next, in this SANS 25 section, there are 25 total vulnerabilities, so all of them don't have labs. Like this is SQL injection, and this is a classic example of SQL injection. And Next, in their OS command injection, OS command is injected. Their path transversal. This is the same as SSR, where user can modify the path and go in deep in the file directory. This is cross-site request for this CSRF. So normal user password is simple. I can log in and my current role is 178. I can transfer some money to some recipient. So, but the transaction is happening through a weak API, and you can exploit that API because the API don't use CSRF memory, and we can send our victims a pre-filled form, and it will be very dangerous. Another important topic is unrestricted file upload of file with dangerous types. Like this vulnerability happens in PHP, like application also mainly, but in Django is very secure, so need not worry about that. Next, about improper authentication, there are 3 layers inside describing the importance of authentication, common practice, pros and cons. So next is command injection. This here we have a port streaming service. You can input the IP address and it will scan all the open port per name. But main thing is this IP is provided to another service internally, and as you can see, I've added the command, extended the command as whoever. So the API have some raw response also. So the raw response that the result for my last one. So this is the user. Next we have again service request version. The lab you have some classic example of service request version. This lab demonstrates how internal service can be exposed because of vulnerabilities in some services. Uncertainty includes the old and errors. So there are a page accessible by the local only. So we need to start the server with some extra parameters. That was like because this local host I can access the page, but if I try to access this thing from outside, parameter the server and start with open IPs. So, so as you can see, I can access this PyGoat web service from this IP address other than my local IP. So, but if I go to this directory, I get access denied because it only accepts the local host. But if I send the request to this utility, I can get the page. And last but not the least, the code injection lab has a simple calculator which is not very simple. It will math expression and it can do some other things also that it should not do. So I can evaluate some simple math expression like this, or some pretty much some more complex math I can use for this calculator. But it has some other features also that it should not have. Like I can import some module, and because this calculator using the eval function, I can pass some import parameters like import math and printing the pi, or I can import OS and do some repeat things also using the calculator. So the user input where also should be sanitized before passing to such a function. So this is it, and I would like to thank my mentor, for always directing and supporting, answering the question, providing feedback and encouraging criticism, while also expressing my interest in security and open source. I was able to complete all of the project's goal thanks to their effort. I appreciate the OSA Foundation allowing me to participate to this project and giving me such a large network of mentors, other contributors for me to learn. For the assistance with this project, the member of the WhatsApp group and PyGoat Slack are also appreciated. Thank you.